Good day and welcome to Numeracy in Mathematics 2. Today we are discussing Unit 2 of Numeracy in Mathematics 2. Welcome, and I hope you're going to enjoy the presentation. I want you to concentrate and listen carefully to the explanation. I will give some examples of how you're going to solve problems and how you do the mathematics that is in this unit. I'm requesting you please to pay close attention to what we are discussing so that you can follow and not get lost behind. First of all, let's look at the outcomes of learning in this unit. Unit 2, you need to know that at the end of the unit, learners should be able to, or students should be able to know the following. You must be able to describe the significance of digit position in a number. Very, very, very important. You need to know the significance of a digit position in the number. You need to know what is the value of this unit and why does it stand, or what does it mean when it is there and when the other one is there next to it, and so on, as you are moving to the left or as you are moving to the right. So it is very important that you should be able to know and to understand these things. We will come to details later. Describe how to use approximation to reduce the complexity of large number and to facilitate control estimation. Very, very critical. Then the other outcomes that you need to know, you need to compare an orders number. You need to compare numbers, you need to compare the orders of number. In other words, if I give you a fraction, you need to phrase that fraction from which one is bigger than the other one and which one is smaller and which one is getting smaller, or so on. You must be able to use the equal sign or greater than sign, those signs. For example, you need to know where to use the equal sign, the greater than, this less than and the greater than sign, and so on. Or there is also another sign called not equal to. All those signs you must be able to use them in your mathematics as you are teaching your learners. Then you must be able to identify and use the different terminology with regard to the four operations: addition, subtraction, division, and multiplication. Those are very, very critical. You need to know the terminology used. You need to understand and to be able to convey those terminology to your learners so that your learners can be able to understand what you are talking about. Devise different strategy for mental arithmetic, how you will teach the learners. You must know that you are not going to teach the same type of learners. Some learners will be too clever, some will be too slow, some will be in the middle, but you need to cater for all of them. So you need to develop those various strategies. And then you must discover patterns in numbers. If you have been given numbers with the commas in between, you must be able to see, is it every time are they adding 2 to the previous number, or are they adding 3, or are they subtracting 3, or are they multiplying by 2, or what? The pattern. What is the sequence? And then outcomes of learning continue. The other one, you need to apply the 4 basic operations as I have discussed about it: plus, minus, division, and multiplication. Explain addition and subtraction as inverse operation. Addition, if you want to go back, subtraction. That is the inverse proportion of that one. You need to explain that proportion. We're going to discuss about that. Explain multiplication and division as the inverse operation. In other words, if you divide, you multiply backwards, if you want to go backwards. So it's the inverse, multiplication and division. And then you need to identify suitable operations to solve 2-step problems. What operation are you going to use? Are you going to use multiplication? Are you going to use addition? And so on. And then you need to describe how to interpret and solve word problem. This one is very critical, and it gives a lot of students some difficulties because you need to read what is in the whole long sentences, and then you must be able to understand and explain and come up to a calculation that will resolve the problem. Count up to 1 million. It is very, very important that you must teach your learners. For example, in this unit, they are asking this, you as a teacher, you must be able to count all the way up to 1 million. How do you do that? Very simple, by adding a number to the previous one, up to 1 million. Now let's start with the place value. Now with the place value, in the decimal number system, the value of a digit depends on its place. That is the very first statements that you need to understand, that each and every number have its own value where it stands. For example, if you are having 2,560, this 0 has its own value, 6 is having its own value. This is having the 5 and the 8. So in other words, this is 1 unit, this is 10, this is 100, and this is 1,000. So usually they usually write it as 1 unit, and this one is 10, and it goes to 100, and this stands for 1,000. So if you have to add or to decompose that number, you can also have 2,000 plus 500 plus 60 plus 0. That gives you 2,560. Now, when you look at this table, there is ones, there is tens. As you come from the bottom to go to the top, you see that there is ones, there is tens, 100,000, 10,000, 100,000, million. And that is how it goes. And that is how the zeros goes as well as you are writing your things. So if you have, for example, 1, and then you have 0 at 10 and 0 at 100, then you have 100. But if you have 1, 0 at 10, 0 at 100, 0 at 1,000, then you have 1,000. So whatever the place value of the last digit, that is the value of that sum. Now, place value, for example, numbers such as 6,495,784 have 7 digits. Each digit is in a different value. And that's what I want you to look at now and discuss in detail. When you look at that, the first digit is called million. That 6 is called million. Is 7 places to your left from unit, 1 unit. You count 7 places to your left, and that is 1 million place value. There are 6 million in the number 649578574. Now, usually, or most of the time, they do not write these numbers with commas and so on. But in the American Standard, they write it with comma. But usually, we write it just 6495784. That is how we write it. And most of the time, they leave space. They will either write 6 and they leave a space, and they write 495 and they leave a space, and then they write 784. And that is how we write. For example, when you are writing our Namibian money, that is how we write. And we write, then you know that this is 6,495,784 Namibian dollars. So what is important is that you need to know the place value of each one of them. This 4 stands for 1 unit, 8 stands for 10, 7 stands for 100, and this is 5 is 1,000, this is 10,000, and it goes on like that. This is 100,000, and this is a million. Now, the second digit tells you how many sets of 100,000s are in the number. The number 6495784 has 400,000. That means this number here, as we say, this stands for 100,000. This stands for million, 100,000. That is the place values for that one. Now, as we are going down, and the third digit is the 10,000 place. There are 9 10,000s in addition to 6 million and in addition to 400,000. That is what it means. And then the other one is the 4-digit is a 1000 place, which is 5 in this example. For example, now this one is number 5, is 1000 place, number 5. And then the 5th digit is the 100 place, which is the 7 in the number 6495784. In other words, that 7 represent 7 hundredths. There are 7 hundredths in this sum. And then the next digit is 8, is the 10th place. In other words, there are 8 tenths in this number. There are 7 700ths in these numbers. Now the other one is 10, which is 8. There are 8 tenth places. The last or right digit is the ones place, which is the 4 in this example. In other words, that 4 that you see there stands in the ones place. The other one is 10, the other one is 100. It will go to 1,000, 10,000, 100,000, and goes all the way up to 1,000,000. Therefore, there are 6 sets of 1,000,000, 4 sets of 100,000, 9 sets of 10,000, 5 sets of 1,000, 7 sets of 100, 8 sets of 10, and 4 ones in the number 64895,784. Very simple. If you understand that, then it will be very easy for you to find the place value, the digit value. If they ask you, what is the place value of this one? Then you will just count from your right hand side to your left hand side, knowing that the right hand side starts with unit 1, and it goes to 10, and it goes to 100, 1,000, 10,000, 100,000, and the million. So that is how we should learn how to count those place values, and it will help us in any other number. For example, if I give you a number like this, 2, 3, 7, 4, and I ask you what is the place value of the 7, you will be able to see it very clearly and very easily that this is now unit 1, so this is 10. So meaning that the 10 here, the 7, there are 7 stand for 10, and 3 stand for 100, and 2 stand for 1,000. So in other words, the 7 is in the 10th value. So it's very easy to do that. Now, example of place value. In the number 4,129, they are asking you the place value of 9 is 9 times 1, because it's in the 1th unit. As 9 is at ones or unit place. Now the place value, and you continue. When you continue the place value for 2, you say 2 times 10, and that is 20. As 2 is in the 10th place. So you multiply it by 10 because it's in the 10th place. When you go to 1, you say 1 times 100, and that is 100, as 1 is in the 100th place. And then you can continue with the 4. The 4 is 4 times 1,000, and that gives you 4,000, as 4 is at the 1,000th place. Very simple and straightforward, very easy to find this value, only if you understand and follow what we are explaining here. Now, let's look at the place value in this diagram here. It's also a very nice diagram that is showing you the place value. Now, this one is a very big number, and also in million. Now, the good thing about this one, the reason why I put it is also that it is having some values after the comma. That is not really for you to teach the learners, because you don't teach that at primary school level, but it's good for you to know. Now, when you start at 5, in this big number 1342365, comma 1427. Please remember, when we are reading a number after the comma, we read all the numbers out. We don't say 1427. No, we say 1427, comma 1427, comma 5, comma 67, comma 688. That is how we read it. We don't read it as a hundredth number or as a tenth number. Now, when you look at number 5 is at the ones unit. Number 6 is at the tenth. Number 3 is at the hundredths. Number 2 is at thousands. Number 4 is 10,000. Number 3 is 100,000. And 1 is in the place of the million as we are going to the left. Now, when you look at the other one after the comma, it is also called tenth, the 1. 4 is called hundredth, thousands, 10,000s as it goes to the left. But remember, this one is actually in a decreasing order. In other words, as the 10, the 1, is actually bigger than 100, which is 4, and is bigger than the 2, which is 1,000. So as you are going to your left, right, it becomes smaller and so on. But as you are coming to your left, it's becoming bigger. So you must just know that after the comma, and this is what I just wanted to inform you, that after the comma, the values as you go to the right, it decreases. Although you read it as thousands, that thousands is actually smaller than the tenth. But as you are going to your left, it becomes, or it increases, it becomes bigger. So please take note of that one and learn it. And it's very good for you to know this type of place values, because it will help you in any other situation where they are asking about place values and so on. Now, let's talk a bit about the standards and expanded notation, because this is something that they very much ask. Say, for example, you have a number 293 as it is showing there. That is a standard notation. A standard form is 393. Now, sometimes they ask you to write that number in an expanded notation. So what do? Since you know already the place value, it will help you to write these numbers out. You know that this is 2 times 100. Why times 100? Because 2 is at the 100th place. 9 is at the 10th place. 3 is just at the unit place. In other words, you have 2 times 100 plus 9 times 10 plus 3. And that is how you write it in expanded notation. I wanted to take another example. For example, say, you have 745. Now they are asking you to write this one in expanded notation. So all what you do is, you know that this 5 is at the units place, 4 is at the 10th, and 7 is at the 700. So in other words, you take 7, multiply by 100, plus 4, multiply by 10, because it's at the 10th place. 7 is times 100, because it's at the 100th place, the place value that we were just talking about, plus 5, because you can't say 5 times 1, because 5 times 1 will still be 1, so you don't need to write that one. So, and that is how you write it in the expanded notation. And that is your answer, what they want to do. Sometimes they give you the expanded notation and they want you to write in a standard form. So they give you a very long number. They say 6 times 1,000 plus 7 times 100 plus 4 times 10 plus 3. A very, very long number. And they are asking you to write this long number in the standard form. So what do? You can see that this one will be the 6,000. That will occupy the thousands place, which is now the 3rd place. And the 7 here plus that times that 100 will give you the 7, which is now 700. And the 4 times 10 will give you the 10th and the 3. And that is your standard form as you are writing that number. Very, very, very simple. But you need to understand the place value for you to be able to understand to write expanded notation or standard form. Estimation and approximation. This is one of the topic that was in the outcomes of learning of this unit. And what is it to estimate? What is it to approximate? Somebody can ask you, for example, how far is Okahanja from Windhoek or Ochakati from Windhoek? And then you can say Ochakati from Windhoek is plus minus 800 kilos. So you are just estimating. It's not exactly that, but it's not really far from that. You cannot say Okahanja Ochakati is, or Windhoek Ochakati is 3,000 kilos, while it is 700 kilos or 800 kilos. Then you are too far. Your estimation must be very close to the truth, or your approximation. You can say approximately so many kilos and so on. Now, what is it? Why do we teach estimation? Why do we need our learners to know these things? It helps us to get a rough answer without calculating. In other words, a guess plus minus answer. So without doing any calculation, you don't need to go and measure now the distance from here to Ochakati and then you say, yeah, no, now I know it's 820 kilometers. But if you know, you are estimating, that's plus minus. Now it can save you from making mistakes, because approximation and estimation usually are not so too wrong, unless you estimate too much or too low. But because they are estimation, they are just plus minus close by and plus minus there. It's not really far away from the other one or far away from the correct answer. So you are just guessing and giving an approximation. And then it helps you to solve problems. Sometimes you have problems or people are asking you questions and you don't know the exact answer. You can say, for example, you were at an accident scene and you were traveling from what place to what place, and you come at a place where there is an accident and police is asking you, what time was that accident? Then you can say, maybe plus minus it was around 3 o'clock, or you was plus minus it was around 4 o'clock. Because you know that the time when you arrive there, or the time when you drive from this place to that place, it was this time. So by the time when you reach there, since you didn't really watch or check your watch, but you can estimate. But you cannot say it was 9 o'clock in the morning or 12 o'clock in the evening. That is way too much or way too wrong. So that's what we are saying, is that we need to teach our learners estimation. You can ask simple questions, give them activities on estimation. You can ask them things like, what do you think, what time do you eat breakfast at home? Or what time do you come to school? What time do you eat lunch? What time do you go to church on Sunday? They can tell you that estimation. No, we go to church at 10 on Sunday or 9 at Sunday. So they're just estimating. Now, inform part of the scientific process. The purpose of estimation is that it gives information to the scientific process, approximately so much. So it gives you an estimate, especially when you are doing these scientific processes and so on. In order to teach estimation, we teach rounding off first. Rounding off whole numbers. For example, you are having a number. You are saying from here to Ochakati is 815 kilometers. That's exactly 815 kilometers. So if I say, with my estimation, I'm saying, no, Ochakati is 800 kilometers, then I'm fine, because that is plus minus 800 kilometers. It's just that there is 15 extra. But for that, to teach you how to round off. Now, if you know that Ochakati is 870 kilometers, I cannot estimate this and say, no, it's 800 kilometers. If I say it's 800 kilometers, then my estimation is very wrong. So, because this 780 is very close to 900, so my estimation should just be, it is 900 kilometers. Because if I say it's 800, that means that there is a whole lot of 70 kilometers above the 800, which is very close to 900. So it's better to have 900 as estimation value for that one. So that's what we are talking about when we are talking about rounding off. Whole numbers can be rounded off to the nearest 10th, 100th, 1,000 or more, or even million, or 10,000. Then I must see that the whole number that was rounded off to the nearest 1,000 is rounder than a number that was rounded off to the nearest 10. Very, very important that you need to let learners understand that if you are rounding off towards 1,000, you jump a lot of places. But if you are rounding off towards 10, it's just maybe 8, you round two places to 10, or 11, you round one place downwards to 10, and so on. But when you are rounding off to thousands, that means you have to skip a lot of numbers. For example, if you are saying is 1,500, then you jump all the way to 2,000, because 500 is very close to 2,000 than to 1,000. And those are the values that they are talking about. Now, 3,853 rounded off to the nearest 10 is 3,850. That 3 becomes a 0, because it is, you must know that the rule is that from 0 to 4, every number there, if the sum end up between 0 to 4, you round it downwards. If it's at 5 to 9, you round it upwards. Now this one is actually 3 is less than 4, so you round it downwards to 0. Now 3,853 rounded off to the nearest 100. Something changed there. Now to the nearest 100, I want you to look at the number 100. The number 100 there is 8. And 8 is very close to 10. So it's 800 actually. And 800 is very close, is 853. So you actually have to look to the number in front of it first. When you look at the units, which is 3, is less than 4. So we keep it that way. But the 5 is more than 4. In other words, the 9 changed to, the 8 changed to 9, and everything becomes 0 and it becomes 900. So in other words, you round up as it is close to the 5 is close to 10 for you to give 1 unit to the 8 to become 9. Now, what if this number was 3843? Then it could not have gone to 900. It could have been 400. If this number was 385, let's say 4. Let's take it 4 here at the place of 5. And there is a 3. Now, since this 3 cannot add to this one, and this 4 cannot add to the 8, in other words, this rounding off to the nearest 100 stays 3,800. That is the tricky part that we need to understand that. Look at the number in front of it. If it's more than 4, change the number on the left to a higher unit and then give the other numbers zeros. Say for example, and that is what we are talking about. Say for example, 8,853 rounded off to the nearest 1,000. Now we are talking about 1,000. Now when you look at 1,000, the place value for 1,000 is held by the number 3. Now you need to look to the number in front of 3, on the right hand side of 3, which is 8. And 8 is close to 10. So we can round off the 3 to a 4 and it becomes 4,000. So when they are asking you, how many people were there? And you know that there were 3,853 people. They're asking how many people were there at the party. Simple, 4,000. You know there were not 4,000. There were a couple of people less than 4,000. But we are estimating close to that one. That is how we do estimation. Decompose and add or subtract, very, very, very important. If you know place value, it becomes very easy for you to compose number and to subtract and decompose. For example, example 1, you have 46 plus 25. Now, 46 breaks into 40 plus 6, and 25 breaks into 20 plus 5. In other words, when you decompose now the 46, it becomes 40 plus 6, and then you add, and then you decompose 25 by saying 20 plus 5, and you decompose them. Now when you have your answer, it will be 40 plus 20 is equal to 60. What happened here? Yeah, is equal to 60, and 6 plus 5 is equal to 11, and 60 plus 11 is 71, and that is how you add those two different values together and you get the answer of 71. For example, the other example is to decompose the number 82. That is the question that they are asking. So when you are decomposing it, is that 8 is in the 10th place, that we know. 2 is in the unit place. So this part of the number can be separated and written as 80. Then 2 is in the ones place, so the part of the number can be separated and written as 2. So when you separate, when you are writing your answer, you will write 82 is equal to 80 plus 2. That is how you decompose it. And then you can also, when you are coming to the other things, you can also use that one to subtract or to add or to multiply. But what you need to know is the place value of that number. If you know the place value of that digit, then you'll be able to decompose those two numbers. Multiply with power of tens. The power of tens are 10, 100, 1,000, 10,000, and it goes all the way to 100,000 to million. So those are the power of 10. Now when you are multiplying with the power of 10, it is very, very, very easy, because all what you do, you just add the number of tens that are there. For example, when you multiply with the power of 10, you add the zeros to the number you multiply with. 45 times 100. All what you do is 45 and you add 2 zeros, because you are multiplying it with 100. If you say 45 times 1,000, you just write 45 plus, and you add 3 zeros. That is 45,000. And that is how it goes. The learner must do this by writing only answers. Very, very important that learners should not use a calculator, especially when they are multiplying this with tens, and so that they can know that if I multiply a number by 100, then I just add 2 zeros to that number. If I multiply a number by 1,000, I add 3 zeros to that number. If I multiply by 10,000, I add 4 zeros, and it goes on like that. So that make the learners practice these things and have them in the system, and they can understand that. If they multiply a decimal number by a power of 10, they just move the comma to the same number of places as 0. For example, you're having 2,345 multiplied by 100. What they do is that if you multiply by 100, there is 2 zeros. So you move the comma 2 places, and it becomes 234.5. If you multiply by 1,000, you move the comma 3 places. If you multiply by 10,000, you move it 4 times. And it is the same with the inverse, because remember in the outcomes we're talking about inverse proportion of multiplication, which is division. If you are dividing by 100, you move the comma to the left 2 times. If you multiply by 1,000, you move the comma to the left 3 times. If you are dividing, you move it to the left. If you're multiplying, you move it to the right. So if you are multiplying by 10, you move 1 time. If you divide by 10, you move 1 time to the left. Multiply by 10, you move 1 time to the right. And that is how it goes for all the other numbers. Now here's some rules of division that I want you to memorize. The number is divisible with 2 if the last digit is even. Every even number you have 2, 4, 6, 8, 0. All these numbers, if you see that a number is a sum end with that number, then you must know that it can be divided by 2. For example, if you have 2, 4, 7, 8, all what you need to do, whether that number is divisible by 2, is look at the last number. If the last number is even, it's an even number, then that whole one will be divisible by 2. And we know the even numbers: 0, 2, 4, 6, 8, and that's all. Those are the even numbers. So any number that ends with those numbers, every number that ends with any one of these numbers, it will be divisible by 2. That's what we are saying. The number is divisible by 4 if the last two digits are divisible by 4. Now, numbers that are divisible by 4 are actually 4, 8. Those are the numbers that are divisible by 4. If the last two digits are divisible by 4, so we can take 4, we can take 8, we can take 12, we can take 16, 20, all those numbers are divisible by 4. So if the last two numbers are divisible by 4, then that number or that sum is divisible by 4. A number is divisible by 8 if the last three digits are divisible by 8. Now here it is now 3 digits. If the last 3 digits are divisible by 8, then that whole number will be divided by 8. A number is divisible by 5 if the last two digits is 5 or 0. 5 or 0 only. Then that number will be divided by 5. Any number that ends with 0, any number that ends with 5, that number is divisible by 5. These rules, they must be taught to the learners so that the learners can know, because especially at pre-primary and primary level, they need to know these rules. A number is divisible by 3 if the last sum of the digit is divisible by 3. In other words, if you can add these two numbers, and these two numbers, for example, this one is giving you 15, if you add them, and is 15 divisible by 3? Yes, then this whole sum will be divisible by 3. That's what they mean. You just add the two last number and you divide it by 3. If it's able to divide by 3, for example, this one, 7 plus 8 is 15. 15 can be divided by 3 and it is equal to 5. That means this whole number here will be divided by 3. A number is divisible by 10 if the last digit is 0. If your last digit is 0, that number can be divided by 10. Simple and straight to the point. Now, patterns of numbers. Let's look at some patterns of numbers, and it's very, very important that you must learn the patterns. I'm not going to discuss a lot of them. I'll just take 2 examples. The first one there, you have a number line. Now, on this number line, numbers are moving from 0 to 17. Now, you notice that the arrows there are showing that it starts with 1. Now, if you add 3 to 1, it moves to 4. If you add 3 to 4, it moves to 7. If you add 3 to 7, it moves to 10. If you add 3 to 10, it gets to 13. 13, you add 3, you go to 16, and it continues. Now they can even ask you, for example, what will be the next following digit or numbers? Then you must be able to follow the pattern. You notice that it is 1, 4, 7, 10, 13, 16, then it will jump to plus 3, it will be 19, plus 3, it will be 22, and it continue and continue and continue. So you need to learn the pattern. Sometimes is subtraction. For example, the bottom one there. The first one is that you add 3 to the previous number. Now the bottom one there is that here is that you subtract 2 from the previous number. For example, you have a number line there that starts from 18 to 26. But then when you start from 17 and you subtract 2, or you start from 25, this one is moving from now right to left. You start from 25, you minus 2, you come to 23. You minus 2, you come to 21. You minus 2, you come to 19. You minus 2, you come to 17. You minus 2, you come to 15, and it will continue like that. So what is important here is that you must learn the pattern. After you know the pattern, you must be able to name the other numbers that are missing. What are the values of the numbers that are following after that one? Addition and subtraction is very important, that you must know the addition and subtraction. For example, you have 3 plus 6 times 5 plus 4 divided by 3 minus 7. Using an order of operation is very, very important, that there are these rules that you must know. The very first one is that you must do the parentheses, which means that you must divide. You must put division in brackets. First, you start with multiplication, and then you go to division, and then you go to addition, and then you go to subtraction. That is the order that you must follow. And this you must teach it to to your learners that they must know that first you do the paraphrasis. In other words, you put the division in a bracket and you solve that one. After that, you go to the number line and you look where is the multiplication and you solve that one. After that, you go to the whole thing and you say where is the division, you divide. And then your addition and then your subtraction. So let's look at step 1. There was 3 plus 6 times 5 plus 4 in the brackets divided by 3 minus 7. And now the parenthesis becomes now the 3 plus 6 is multiplied by 9. Where did you get the 9? Because you add 5 plus 4. And then minus 3 plus, divided by 3 minus 7. And that is your parenthesis there. Now, after the parenthesis, you do multiplication. You go and look, where is it that I can multiply? The only place that you can multiply in that sum is 6 times 9. And then you do that multiplication and you get 54. And then you do the division. You divide 54 divided by 3 and you get 18. Now you do the addition. Now the only addition that is there is 3 plus 18. And that gives you 21 minus 7. 3 plus 18, and it is minus 7. So the 3 plus 18 gives you 21 minus 7, and your answer is 14 when you do the subtraction. That is your final answer. Now, it is very critical that if you don't follow these rules, you will not arrive to the correct answer. Because you will do, for example, if you do first addition, and then you do subtraction, and then you do another multiplication and another division, you will not come to the same answer. So it's very important that you do the parentheses first, and multiplication, division, addition, and last, the subtraction. So that is very important for that one. Now, addition of fractions, I was looking at this too. There are 3 fractions there. 1 over 16 plus 3 over 16 plus 5 over 16. What is the answer? So the answer there is 9 over 16. Very simple. You just add the denominators, the nominators, because the denominators are all the same. They are all 16, 16, 16. But it is not the same case when the denominators are different. Then we do something different. For example, find the value of 13 over 16 plus 7 over 12. Now the 16 and the 12 are not the same denominator, so we cannot just add 13 plus 7. We can't. So we have this one that is also having another subtraction of 5 over 6 minus 7 over 32. So first of all, we need to find what is the lowest common denominator for all these 16, 12, 6, and 32. So, and the lowest common denominator there is 92. So what we do is that we say 16 goes into 92, and we find out, and you add the 13. 12 goes into 92, and you find out what is the value there, and you add the 7. And then you minus 6 goes into 92, you find the value plus the 5. And that is how you go until you find your final value, which is 11 over 33. This one I put it deliberately there, and it's kind of a challenge, but it's that you need to understand how you come up to the final value. And that is that you find the lowest common denominator, you take the denominator and you divide it into that, and then you add the value that is on top. Look at this one, which is a multiplication as well. 2 over 5 multiplied by 3 over 7. So what you simply do, because this one is multiplication, we don't need to find out the lowest common denominator and stuff. All what we need to do is multiply the denominator with the denominator, multiply the numerator with the numerator, and then you have 2 times 3, which is 6, and 5 times 7, which is 35, and that is straight to the point, to the answer. Now, let's come to the word problem, which will be our final discussion for today. Now, word problems could be very challenging to learners to comprehend. So the teacher needs to train learners to follow the following procedure to solve word problem. First of all, they must read and interpret the story or the problem. So word problem is things like John was sent to the shop with $5. He bought sweets for $2 and was given how much change? Those kind of problems. So it's a whole lot of writings with numbers inside. So you need to teach the learners how to find out what is the problem. So for example, there what they are looking for is what is the change, or how much money does it get for change, and so on. Then decide on a strategy to use. After you find out the problem is they are looking for change, then you must decide, how do I find the change? So you need to look for a strategy to use, or maybe you're going to multiply, or you're going to divide, or you're going to add or subtract, and so on. So you need first to decide that. Record the working process. In other words, you can write it out. I will first look at how much he has and how much it costs and how much is left with him, and so on. And then record the working process, as you say, and then explain your method to the class or the group. Do not come to the class with a word problem that you didn't solve already. It will be an embarrassment if you are struggling then to solve this word problem in front of the learners. You need to solve the problem already, so that when you come to class to teach the learner, you already know what is the solution of that problem, rather than coming and finding out in front of the learners what is the working process. So then you need to explain your method to the class or to the group that you are teaching, so that they can know what is your method. Listen to the explanation of the other learners in a class or group. In other words, also challenge them with some questions and so on. What do you think? What do you think should we solve? How do we solve this problem? How will you want this problem to be solved, and so on? So you need to challenge the learners also, so that they can be able to think and come up with possible solutions also. And to define the possible mistakes and correct the mistake, if any. Now, let's look at one example of a word problem. Here we have the problem of Sarah. Sarah have 1,500 and decided to invest in different banks. She put a quarter in FNB, 2/3 in Standard Bank, and the rest she put in Bank Windhoek. A quarter, 1/4 in FNB, 2/3 in Standard Bank, and the rest she put in Bank Windhoek. How much money is put in Bank Windhoek? Now, for you to solve this problem, you need to know that here there is fractions. The money is not in dollars and whatever. We know it's 1,500, but the investment is invested in terms of fractions. So we first need to know how much is 1/4, how much is 2/3. That is one way that you can do it. Or if you want to do it the other way, because I show two ways here, I will show you this way and then I'll show you the way of doing it, just finding out how much straight from the fractions. Now, the first one that I was doing here is that 1/4 plus 2/3 plus C, which is now the value for Bank Windhoek. C is now actually Bank Windhoek, should be equal to 1, for example, because I want to know what fraction did he put in Bank Windhoek. Now, for me to find the fraction, first I add the two fractions together, 1/4 plus 2/3. We know that the lowest common denominator is 12, so I add the way we were just adding before, and I get 11/12 plus C is equal to 1. Now, for me to find C, I take the 11/12 to the other side and I subtract it from 1. Now I have C is equal to 1/1 plus, not plus, but it's minus 11/12, and that gives you 1/12. The calculation there is actually minus, not plus. So when you minus 1/1 minus 11/12, it gives you 1/12. Now the fraction for Bank Windhoek is actually 1/12. Now, for me to find out what is the value for that money, I take 1,500 multiplied by 1/12, and that gives you 125 paid to Bank Windhoek. Now, I can also do it the other way around. What I do, and which is also a bit more simpler, is that you take 1/4 multiplied by 1,500. In other words, you just want to simply find out 1/4, how much money is it? So what you do is that you take 1,500 divided by 4. Or you can say 1/4 multiplied by 1,500. And that is equal to 375. 375. That is the money that went to FNB. These things are dead. That's the money that went to FNB. Now, if I want to find out how much money went to Standard Bank, then we know that Standard Bank is 2/3. I multiply that by 1,500, and then I get that answer, because here it will be 2/3 multiplied by 1,500, and that is equal to $1,000. In other words, 1,000 went to Standard Bank, 375 she put it in FNB. This is Standard Bank. And then the last one is the one that we don't know. Now, you can actually use these two amounts to get the third one. So let's see whether it will give us the same answer. So you have 375 plus 1,000 minus 1,500. It should give you that amount that you are looking for. In other words, here you have 1,375 minus 1,500. So in other words, the money that she put there in that bank is 125 for this one. And that is exactly the same as we find it there. For Bank Windhoek is 125, Standard Bank is 1,000, FNB is 375. And that is how we do that calculation, which is very simple, that you need to know, first you need to know what is a strategy. What strategy am I going to use? What method am I going to follow? After that, it will become easy for you to do that. Thank you.